Okay. Hi everyone. Good evening. Today's session, we are going to talk about one of the vSphere cluster features. In our previous session, we already talked about DRS, DPM, and high availability HA. And today's concept is fault tolerance. In short form, we call it as FT. Okay. So within our today's agenda, let me same like previous. Quickly recap the vSphere cluster features overview, and then we'll start with the fault tolerance architecture. And before jumping to the deep dive architecture, I will just show you where we can enable a fault tolerance option, on enabling a fault tolerance on your VM, and how fault tolerance work, and also FT features, FT configuration limits as per the VMware configuration maximum guide, and FT with high availability and DRS, and FT redundant Vmdk files and fast check pointing. And remember, how the FT works means the backend main FT technology name is fast checkpointing technology. Okay, this is the technology in the backend, and the FT shared files, and we can perform the home lab. Usually for FT, we require some specifications like Enterprise Plus license, and also the one of the minimum requirement for FT is 10 Gbps network speed. But in our home lab, we have only the 1 Gbps network speed. But we'll try how the FT functionality and all in our home lab. Okay, and finally, we'll verify the vSphere features in the real-time scenarios. And this diagram we are already familiar. As per the organization structure, we have a ESXi host and virtual machines, and there is some known common issues. So as we familiar, when we have any ESX host unexpectedly down or anything, we go for a HA and fault tolerance. As we know, HA is mainly for a 99.99%, and fault tolerance is mainly for a 100% availability. That means continuous availability for virtual machines. If the virtual machine is mission critical VM, we can use a FT, and it will provide you to the application owners to 100% availability. Okay, and for resource crunch and underutilized scenario, we'll go for a DRS and DPM. And for the any of the data protection perspective and the site protection perspective, we'll go for a replication or SRM. Okay, and this is a high level protection at every level conceptual diagram. So DRS, DPM we are familiar, and HA also familiar. Now we focus on a fault tolerance. And vSphere clusters overview, even whenever we create a cluster, the default features it comes with a DRS, HA and vCenter. We can enable all these features while creation of cluster. Within a cluster only, we can able to enable fault tolerance. Okay, fault tolerance also comes under the cluster feature. So vSphere fault tolerance, and within a cluster, we are going to enabling a fast checkpoint. This is a symbol for fast checkpointing symbol, and even fault tolerance uses a fast checkpointing. Fast checkpointing is nothing but a continuous copying. That is our main technology in the fault tolerance backend. So before jump into the complete FT architecture, we'll start with a basic step first. And within a fault tolerance architecture, if you want to enable a fault tolerance on a virtual machine level, you can just log into the vCenter and select any one virtual machine. That virtual machine should be either a production critical application or any mission critical application. Mission critical is nothing but a, if that application is down for a minute or down for a few seconds also, there is a huge impact. For example, Google website, even if you imagine the Google website down for 1 minute, the entire globe worldwide it will be impacted for the search engine. So that is a very critical server, a Google web server. Same like in a organization level also, there is a company websites or any of the internal websites and HR portal, any type of websites normally considered as a critical web servers. And similarly, there is some application layer also, there is a mission critical servers. Those scenarios, customer always requested the clients to provide a 100% availability. When you any specific mission critical VM requires a high 100% availability, you can log into the vCenter server and go to the specific cluster where this critical VM running. log into that specific cluster, select that cluster and choose the particular VM, right click, and within the right click options, you can see the option for a fault tolerance. So fault tolerance, and again, if you go to the drop down menu, you can see turn on fault tolerance. So this is the option where we can turn on a virtual machine fault tolerance. And even if you want to turn off, there is a turn off option also. After turn on, these options will be automatically highlighted. Present it is in a grayed out situation. It's a turn off also you can do, and same like virtual machine power cycle options. You can resume the fault tolerance, you can suspend the fault tolerance, and you can migrate the secondary VM, test failover, and you can test the restart secondary. These are all the tasks you can perform using this fault tolerance tab. And so the same point I highlighted in the description. We can turn on the vSphere fault tolerance for a VM using vSphere client. Even to connect to the vCenter server, we are using a vSphere client only. For example, quickly log into our lab system. So let's log into our vCenter server using the vSphere client. See, when we log into the vCenter server using the vSphere client, see, we have a three clusters are available, but most of the ESX running on a production cluster. The remaining cluster, just for our understanding, we created. And if you expand your production cluster, see, there are few ESX hosts are in a maintenance mode. Okay, let's remove the host from maintenance mode. And if there is any known warnings, just to clear those known warnings. Okay, so we have 4 ESX hosts, ESX 1, 2, 3, and 4, and the 3 virtual machines are power on state, and another VM is showing as inaccessible state. Just as for testing purpose, if I select any one random virtual machine, let's say VRA, vRealize Automation Server, right click the VM, you can see the option for fault tolerance. See, turn on fault tolerance. But only the condition, if you want to turn on the fault tolerance, the main conditions, all the conditions, cluster feature conditions are similar like vMotion conditions. What is the vMotion conditions we have? We have the basic requirement for vMotion is all the cluster ESXi host CPU family should be same, technology should be same, and we require a minimum 1 Gbps network. But for fault tolerance, VMware recommendation is 10 Gbps network. And apart from that, they require a fully qualified domain name and enough resources on in our cluster. All the features applicable for fault tolerance also. But the one basic condition, it should be in a shared storage. But our VRA, IDM and all running on a local data store. So we'll try to power on the test VM, our Windows 10 VM01. Before power on, it is showing as inaccessible. Okay, just if it is showing inaccessible means, let's verify we have a shared data store available or not. Okay, it's currently shared data store not available. That's why it's showing the status as inaccessible. So if the iSCSI shared data store not available means, just go to the configuration tab. Under the configuration tab, select the storage devices. Already our devices are added. Okay, we have a iSCSI software adapter. Just you can do the rescan. Okay, it will rescan for new storage device and new VMFS volume. Click on OK. So rescan is still, it may take some time to run the rescan. See, rescan VMFS, rescan HPA completed. Now you can go to the data store tab. See, iSCSI data store is accessible now. And same way, select the ESX2. Here also not shared data store is not accessing. Go to configure tab, click on rescan. And similarly to the ESX3 also, I think no share. Okay, it's added automatically. And ESX4 also no shared data store. Go to configure tab, rescan. ESX2 data store tab. Okay, when I click the data store, shared data store, see all the ESX hosts are now accessible to the iSCSI data store. Now go to the cluster and see the virtual machine status is inaccessible. It's back to normal. Okay, and it is also trying to power on now. It's in the booting stage. Okay, it's fine. But the only thing now our objective is VM should be on a shared data store. And if you want to enable the fault tolerance, we can turn on the fault tolerance. Okay, so before turn on the fault tolerance, let's try to deep dive into the remaining concepts. So now we'll talk about a fault tolerance architecture. See, within a fault tolerance architecture, when we turn on the fault tolerance, we just observe how to turn on the fault tolerance. When we turn on a fault tolerance on mission critical or any critical application VM, when we turn on the fault tolerance, what will happen is VMware fault tolerance create two complete virtual machines. So it's create first, this is a primary VM, and when we enable fault tolerance, it will create a secondary copy also. That secondary copy, we call it as a secondary virtual machine, and the first one is primary virtual machine. And copy means whatever the files we have in the source virtual machine, like VMX file, it consists of CPU memory configuration detail, and Vmdk file, it consists of all the virtual machine disk data, and the network file, it have a network device information. All this information is copied to the secondary VM. So that is the same point highlighted here. vSphere FT create to complete virtual machine when enabled with vSphere 7. Okay, when enable only, it will create the secondary copy. This includes the complete copy of VMX configuration files. So it has VMX configuration file and VMDK files, including the ability to use separate data store. They are recommending, if you want to enable the FT, we also require a separate data stores. So the secondary copy always copy to the second data store to avoid the data store failure issues also. Okay, so primary will volume virtual machine will be on a data store 1, and the secondary virtual machine will be on a other data store like data store 2. Okay, so that is a one key point in architecture. Now let's dive into the some more. Within the FT architecture, it is an availability solution, same like high availability feature, but it is same point, is an availability solution that provides continuous availability for virtual machines. So continuous availability means no downtime. We can also say zero downtime, zero data loss. Okay, that is a key point here. And also no loss of TCP connections. TCP connection is nothing but a transmission control protocol connection, which is like a network. Even if you ping the any system, there will be no network ping drops. Suppose if you enable FT on any one production virtual machine, if you test the ping connection status, always continuous ping response only, there will be no TCP connection drop. Okay, and completely transparent to guest software. Even if you enable FT, it's always there is no impact on your guest OS and guest operating system software. So the same point in the following point, no dependency on guest operating system applications, and no application specific management and learning. Even if you enable the fault tolerance on virtual machine level, there will be no impact to your guest operating system and also the running applications and all. Okay, and how the FT is supporting is it's supporting up to 8 virtual CPUs and 128 GB of RAM in virtual machines with 7.0 version. Even if your virtual machine is maximum up to 8 virtual CPU, we can enable FT. If your virtual machine is running with more than 8 virtual CPU, FT feature is not supporting. Okay, at present VMware 7 series version, they are giving support up to 8 virtual CPUs. Suppose in the previous editions of 6 series editions, VMware given the support up to 4 virtual CPUs only. If your virtual machine is running with more than 4 vCPU, even FT functionality will not work. And some more limitations, configuration limits, I will show you in the following slides. Okay, and this is the max limit. If you want to enable the FT on a virtual machine level, it supports max CPU 8 CPU and memory 128 GB memory. If your VM is running more than 128 GB memory, our FT for future will not support it. Okay, and if you see the architecture diagram, this is the architecture diagram. For FT enablement, minimum we require a 2 ESX host, and recommendation is 3 ESX host at least. Okay, minimum is 2, my recommendation is 3 ESX host. Suppose if in this diagram we have a 3 ESX host and we enable the fault tolerance on virtual machine layer, when we enable a fault tolerance on VM layer, this is the fast checkpointing technology. Fast checkpointing is nothing but a fast continuous copying technology. Using that fast checkpointing technology, this virtual machine will create a secondary copy on another ESXi host. Okay, so when we copy a VM on a second ESXi host, we are not sure when the another ESX host may down. So that is the reason in this diagram I just shown as a there is a one failed server. So when the ESXi host is unexpectedly down, what will happen is immediately it will prepare another secondary copy. Okay, so there will be no impact to the production. So if we copying secondary copy and even our primary VM is working up and running normally, that means no reboot, seamless cutover. Okay, so this point only we highlighted here. No loss of TCP connection, zero downtime, and zero data loss. But actual functionality, how the FT works, we'll discuss in the following slide. So I just elaborated some more the how the FT works. See, vSphere FT provides instantaneous failover. So within milliseconds, fraction of milliseconds, the VM secondary VM will be become as a primary and also continuous availability. So that we already observed these 3 points: zero downtime, zero data loss, no loss of TCP connection. Now let's try to understand the visualization figure how the FT is working. For example, I took the minimum recommendation to enable FT. We require minimally within a cluster, we require two ESX hosts. So I took the two ESX hosts, ESXi 01 and ESXi 02. And these two hosts are configured with a cluster. So already both ESX are in a part of a cluster. And then we created a one production virtual machine. Let's say the first virtual machine production VM, we call it as a primary virtual machine. And if we want to enable a FT option, how we can enable, log into the vCenter, go to the specific cluster and right click the virtual machine, we can enable FT. When we enable the FT option on a specific primary virtual machine, what it will happen is immediately it will create a secondary copy. That secondary virtual machine is created using a fast checkpointing technology. Checkpointing is nothing but a continuous copying. Okay, so fast checkpointing, it will immediately it will create a secondary copy. That is the reason if you want to create immediate within few seconds, it will require a secondary copy. VMware recommending the network speed is recommended network speed is 10 Gbps. Okay, within the 10 Gbps network speed, immediately it will create a secondary copy, and whatever the user doing the changes on a primary virtual machine, all the changes it's keep continuously copying to secondary VM. But the thing is, this secondary VM is completely have a different universal unique ID, and the data store will also a different data store. There will be no impact to the production VM using this secondary virtual machine. But suppose the fault tolerance, the main failure scenarios are two scenarios. One failure scenario is either ESXi host may down at any time. For example, if the ESXi host unexpectedly down, or another scenario is there is a chance of our production virtual machine may get hang. It will completely become as a hang state. So during these two scenarios, what will happen is we already enable a fault tolerance. When we enable fault tolerance, what it will happen is it will immediately fail over. That means when your primary virtual machine is down, our secondary virtual machine acts as a primary virtual machine within fraction of seconds. So even user also user will not aware we are already running on a secondary copy, but secondary copy is make it as a primary automatically using FT instantaneous failover, and immediately it's create another copy also. Okay, because it's always maintain a one copy, additional copy. Okay, so that is the functionality of how FT is working. And if the availability perspective in vCenter cluster feature, if you see the high availability is it's like a when ESXi host down, the virtual machines are migrate and restarted on another ESX. That means all virtual machine have a single reboot. So that is the reason we say the percentage for the availability percentage is 99.99%. And when comes to the fault tolerance, there is no chance of migrate and restart concept. We are every virtual machine, whatever the VM enabled with a fault tolerance, it have a secondary copy. When the virtual machine not receiving any heartbeat, either network heartbeat or storage heartbeat, immediately secondary VM thinks that our primary virtual machine is down, and it will immediately it acts like a primary VM, and it will prepare a second copy. Okay, that is a hefty working functionality. But how this copy creating, how it is synchronizing the data from primary to secondary is using the fast checkpointing technology. Okay, and I also highlighted checkpointing means continuous copying. Okay, but in our when we see our vMotion concept, the checkpointing pre-copy is our memory bitmap is copying only one time during the migration. But in the FT scenario, it is not like one time pre-copy from source to destination. It is like a continuous copying from source to destination. Even that continuous copy also not like normal copy, it's a fast copying. That fast copying also, whatever the changes did the user on the virtual machine level, all the changes will be updated and synchronized with a secondary virtual machine. Okay, this is the FT working functionality. In the following slide, whatever we discussed from this diagram, all the description I highlighted in the following slide. See the description, will quickly run through the description also. We can use fault tolerance for most mission critical VMs. Yes, it's only for mission critical VMs. And FT provides continuous availability for such a virtual machine by creating and maintaining another VM. So another VM is nothing but a second copy, and that is identical. Identical means it's almost like a similar copy and continuously available to replace it in the event of failover situation. Any failover situation, either ESXi host down or our production virtual machine down, there will be no impact. The secondary copy is acts like a primary copy, primary virtual machine. So the protected virtual machine is called primary VM and the duplicate VM is called secondary VM. It is created and runs on another host. The primary VM is continuously replicated to secondary VM so that secondary VM can take over at any point without interruption and providing a fault tolerant protection. Here, fault tolerant is nothing but a easiness. In case of any fault also, it's easily we can protect. That is the meaning of fault tolerant protection. And the primary and secondary VMs continuously monitor the status of one another. It's the same like how in our previous concept high availability, our fault domain manager every 15 seconds it sends a heartbeat from master host to all our second subordinate hosts. It will keep on sending the heartbeats at any certain time. If it is unable to send the heartbeat, it decides that our associated or subordinate host is down. Similar scenario in our fault tolerance also, it's always continuously monitor the state of one another to ensure fault tolerance is maintained. They always keep on sending the, but in our ESXi host HA scenario, it's 15 seconds. But when comes to the fault tolerance scenario, it completely like a 10 milliseconds. Every 10 milliseconds, it will send a heartbeat. Okay, and the transparent failover occurs if the host running the primary virtual machine fails. So the when the failover occurs, it's completely depend on a primary virtual machine file or a host file. Encounter an uncorrectable hardware error. Even ESXi host level, if you have any unknown or unexpected hardware errors also, immediately the failover will start. The memory of the primary VM, in which case secondary is immediately activated to replace the primary VM. And a new secondary VM is started because our primary VM is already dead and secondary VM become as primary, and immediately within our fault tolerance network, it will create a secondary copy also. That is also it's automated functionality. We no need to do anything manual activity. Our only manual activity is just to turn on fault tolerance. Okay, and after that every portion will be automated. A new secondary VM is started and fault tolerance redundancy is re-established automatically. Okay, if the host running the secondary VM fails, it is also immediately replaced. Even not only primary virtual machine down, even the secondary virtual machine down also, it is also same functionality. It will prepare a secondary copy immediately. Okay, after preparing the secondary copy, again fast checkpointing will work. It will continuously copying the data from source to destination, and it will always synchronize the data. Okay, and in either case means either primary file or destination secondary copy files, user experience no interruption. User will not aware backend there was some VM down and it's up from the second copy. User will not aware, so user experience as a no interruption in service, and no loss of data, and 100% availability for FT enabled virtual machines. Okay, and so we just observe for one virtual machine how to enable the same scenario. We can enable the fault tolerance for all your mission critical and production application servers. Okay, it's subjected to be customer's choice. Some customers, they may use only the high availability feature, and some customer they will use high availability and fault tolerance, which are both features they will use. Okay, and now, what is the features we will benefited from the fault tolerance? Let's talk about the features information. See, vSphere fault tolerance protects mission critical virtual machines and high performance applications. See, this is the two scenarios. Either you can enable FT for mission critical VM and also the high performance applications, regardless of the operating system used. Operating system can be either Windows, Linux, Solaris, any other operating system, which are all supported for vSphere platform, and supports up to 4 FTVMs per host. Even if you want to enable fault tolerance on one ESXi host, it supported maximum 4 fault tolerance VMs only per ESXi host, and with no more than 8 vCPUs between them. Even if you enable a 4 VMs also, overall CPU should be 8 virtual CPU. That means each VM we should maintain a 2 vCPU. So 4 multiplied by 2 is equivalent to 8. Okay, but we cannot enable the within a vCenter. Max supported is 8 CPUs only for virtual machines, and supports vSphere vMotion migration for primary and secondary VMs. And even vMotion also is supported when we enable a fault tolerance. There will be no impact for a vMotion task, and creates a secondary copy of all virtual machine files and disk. Even secondary copy consists of a all VM files and disk files, and provides fast checkpoint. This is the main technology for FT. So fast checkpoint copying to keep primary and secondary CPUs are synchronized, and supports multiple VM disk formats. So disk format also for FT there is no limit restrictions. You can use either thin disk provision or thick provision, either lazy zeroed or eager zeroed, and can be used with vSphere DRS only. Even the FT is uses a DRS technology when EVC is enabled. EVC means enhanced vMotion compatibility, and supports interoperability with interoperability with vSAN. So even if you have a vSAN in your vCenter environment, there will be no impact. FT is still compatible with virtual SAN. Okay, and now we can going to talk about the complete fault tolerance configuration maximum limits. So this is the FT maximums within our vSphere 7 environment. So virtual CPUs per FTVM max is 8 CPU, and vCPU per host, even within one host also 8 CPU only. That means if you have 4 VMs, we need to reduce your CPU count to 2 to 2. So 4 into 2, 8. Per host means it support only for 8 vCPU only. And RAM per one virtual machine is 128 GB, and virtual disk per host, even max it supported the FT technology up to 16 disks, and the size also disk per host overall size also max size is 2 terabyte, and FT virtual machines per host. Even how many VMs is 4 virtual machines only, and FT VMs per cluster, even within a cluster level 98, and FT VMs virtual CPUs per cluster 256. But here we no need to multiply 4 into 98 like that, or 4 into 8 into 98. If you multiply, it will be huge count. But the limitation VMware giving for FT VMs vCPU per cluster is 256. Okay. This is as per the VMware official configuration guide. And now we'll talk about how FT functionality will work with vSphere cluster HA and DRS. See, within our vSphere FT HA and DRS, how it will work is like if we have a HA is already enabled and DRS also enabled in our cluster. So vSphere HA and DRS are fault tolerance aware. Even fault tolerance will be aware of these two features. When the HA is enabled, is required for vSphere fault tolerance. That means even if you want to enable a fault tolerance feature, we require minimum requirement is cluster should be enabled with HA feature. Okay, and restart failed VMs. Even there will be no impact to the HA functionality. It will still work like a same like as usual. It will restart the failed VMs to another ESX host. And Vsphere DRS scenario. DRS is required in a FT functionality only if you have a enhanced vMotion compatibility enabled. Okay, and select which host run primary and which host run on a secondary when the VM is powered on. That options are still function even if you have a FT feature, and does not automatically migrate the fault tolerance VMs. See, only the restriction in the DRS is it won't migrate automatically because the fault tolerance is enabled. Instead of migrating the fault tolerance VM, DRS will take care to balance the load using a other virtual machines. It will initiate the migration. Okay, suppose in this diagram we have a fault tolerance is enabled here, and fault tolerance means minimally 2 ESX, or you can use recommended 3 ESX hosts. ESX1 have a 3 virtual machine, ESX2 have a 2 virtual machine, and 3 also have 2 virtual machine. Let's say all of the sudden either ESXi host or virtual machine, any scenario if the virtual machine is down, primary virtual machine is not able to communicate to our secondary virtual machine. What will happen? Our primary virtual machine communication is lost. So immediately what will happen is this primary virtual machine is down and the secondary copy is become as a primary, and again it will prepare a new secondary copy on another ESX host. This is also functionality, but how it is immediately creating is using a fast provisioning technology. Okay, and during the migration and all, it still uses a DRS normal migration. Okay, and immediately it's become the secondary to primary and prepared a new secondary machine. Even once this ESXi host or virtual machine is back also, there will be no impact. It's always maintain only one single copy only. Okay, it won't maintain a multiple copies, one primary copy and one secondary copy of virtual machine. Clear? Now we'll talk about some additional points. So within the HADRS, additional point is a FT primary VM and its secondary copy are not allowed to run on a same ESX host. So even if you see the diagram, it's not always recommend to run on a same ESX host. Secondary copy should run on a always on a different or separated ESXi host only. Okay, the restriction ensure that host failure cannot result in a loss of both VMs. The only purpose of maintaining a separate host is just to avoid, if we maintain both VMs on same host, even if the host is down, no use of enabling a fault tolerance. So that is the reason VMware recommend that always maintain both VMs on a separate ESXi host. Okay, so when the primary virtual machine is down, what will happen? This primary will become a secondary VM become as a primary, and it will prepare a another secondary copy. Okay, this is the functionality, FT functionality. And FT, if you want to enable FT also, we require a vSphere HA, and DRS is required only if you enable a EVC mode. Okay, now it's already copied a primary to secondary copy, but how about my data? How the situation for my virtual machine file, primary virtual machine file and the secondary virtual machine file? It's always the same copy. How we in our previous lab we tested for a clone virtual machine, or we deployed a virtual machine from template. Even if you deploy virtual machine from template or create a duplicate copy, always the same like source virtual machine. We have VMX file, Vmdk file, all files are same, but only thing is it maintain a different UUID, universal unique identity. Okay, so that there will be no naming convention issues and there will be no conflicts in the network. Okay, so now we'll talk about a Vmdk, redundant Vmdk files between the primary virtual machine and secondary virtual machines now. See, within the vSphere FT architecture, we can talk about redundant Vmdk files. Redundancy means able to recover, it always maintain a second copy. And vSphere FT provides failover redundancy by creating a two full VM copies. The first copy is primary, second copy is secondary. Okay, and each VM has its own VMX file, and the configuration VMX file means configuration file, and it also have a Vmdk file. Suppose my source VM primary virtual machine is running with the 3 Vmdk files. When you prepare a copy also, it prepare a same 3 Vmdk files. But only difference is primary VM running on data store 1 and secondary VM is run on a data store 2. And the same point highlighted in the third point, each VM can be on a different data store. Okay, why we need to create on a different data store is to avoid the data store failure scenario. Suppose if you prepared secondary copy also in the same data store, if your data store having some connectivity issues, immediately both VMs also down. Okay, so to avoid that situation, what VMware recommend is, in some cases both VM files can be placed on the same data store, but vSphere FT place these VM files on a separate data store. Even if you create the another copy also on the same data store, after some time FT will automatically place, means it's move these files to separate data store to provide recovery from data store failures. Okay, so this is the important point, redundant Vmdk files. And now we'll talk about a network scenario. What is a FT network for vSphere FT? See, vSphere FT checkpoint. So changes on the primary VM are not processed on the secondary. That means whatever changes you did on the virtual machine CPU layer and all, that will not change, but it will, how it will sending the changes from source to destination is, it is through the memory bitmap, same like our vSphere vMotion. The memory is updated on a secondary virtual machine. Okay, how it will update? It is updating through FT network. That means we also need a separate VM kernel port group enabled with a FT service. Okay, like FT management network is needed on both ESXi hosts, and the same FT network it will uses during the copy and checkpointing, continuous copying scenario. And let's talk about in detail about the memory checkpointing or pre-copy. See, memory checkpoint pre-copy, even if you see here in this diagram, we have memory bitmap. It is same concept like our vMotion concept. But in the vMotion concept, we do it to copy only one time migration copy once only. But here is a continuous copy. Okay, let's talk about the description. vSphere FT in vSphere 7.0 uses fast checkpoint technology. Okay, this is important point. Some of the interviews or VCP certification exam, they will ask what is the technology uses in FT. The technology name is fast checkpointing. But in our previous vSphere editions, the technology name is called it as vlock step technology in our previous editions. But from the latest edition from 6.5 onwards, the technology name is changed to fast checkpointing technology. And this is like how vSphere vMotion works, but it is done continuously rather than once. Okay, and the fast checkpoint is a snapshot of all data, not just memory. So all data means it will include a memory, disk information, disk data, devices information, that means virtual devices, and so on. So even if you see in this diagram, our ESX1 is running with VMA primary VM. The secondary copy also same like VMA. But how it is copying the data is using the fast checkpoint technology, and it will uses a vSphere FT logging network. This is within our VM kernel port group. We need to enable a FT option. Okay, and normally for virtual machine communication, we have a virtual machine port group, and memory bitmap is nothing but what is the changes happen, like primary changes stored on a RAM. That RAM changes memory bitmap also copying through ESX to secondary VM. It's always sync the data between primary and secondary virtual machine. And here I highlighted the network recommendation. VMware FT logging network. This logging network has a minimum requirement of 10 Gbps. So not only recommendation, VMware says that minimum requirement is 10 Gbps NIC. Okay, but in our lab we have 1 GB NIC. We'll just try to test it how it will function the when we enable a FT functionality. Okay, and using vSphere FT, a second VM is created on the secondary host, and the memory of the source virtual machine is then copied to the secondary host. Okay, now we'll talk about a fast checkpointing. How the fast checkpointing is will be happening. See, the fast checkpointing is the actual backend technology. The vSphere FT checkpoint interval is dynamic. Dynamic means it's automatic only. We don't need to bother about the synchronization. It's automatically copying the data from source to destination. Okay, and it adopts maximum workload performance can change from as small as a few milliseconds to as large as several hundred milliseconds. So it's like the virtual machine consists of VMX configuration file and virtual devices, virtual machine disk, and virtual machine memory. And our checkpoint, when we enable, it's a keep copying whatever the changes user performing on the source VM, all the continuous copying to the destination VM. That is called checkpoint. But how it is copying? It is copying through the our vSphere fault tolerance network. Okay, so some more fast checkpoint additional points. Let me elaborate from the next slide. So in our FT checkpointing, the vSphere FT uses an algorithm. What algorithm it uses is it that provides a fast continuous copying. That means checkpointing of the primary host VM from the primary host virtual machine. Okay, the primary VM is copied checkpointed periodically. Whatever the when the user is did some change on the source VM, that periodic changes also it's updated to the secondary VM. That copy is sent to a secondary VM. If the primary host VM fail, even if the host fail or virtual machine fail, any scenario, the VM continues the secondary host at the point of last network send. Let's say at one certain point, the already checkpoint reached the destination and source VM is down. At that time, immediately the goal is to take the checkpoints of virtual machine at least every 10 milliseconds, and the primary VM is continuously copied, and these copies are sent to secondary host. The initial copy is created using a modified form of vSphere vMotion migration to the secondary host. Okay, this is how the checkpointing is working. It's a keep trying to copy from source to destination. Okay, so now let's talk about the shared files. The FT during the FT enablement time in our data store layer, it's created a mainly two files. That two files importance we'll discuss now. Okay, within our FT shared files, we have a two files it's created. One file is shared vmft file and another file is .ft generation file. These two files are very important when we enable a virtual machine fault tolerance. It's like a normally virtual machine files we are aware, like vmx, vmdk, nvram and log file. Suppose if you create a snapshot, it will create additional three snapshot files like .vms and .vmsd, and it will also create a delta.vmdk. Suppose if you convert your virtual machine to template, when you make the virtual machine to template, instead of vmx file, it's created a .vmtx file. Similarly, if you enable a fault tolerance on your source virtual machine, in our data store, it will create a additional virtual shared files. Those shared files called shared.vmft. The name itself, it's have a ft file and also .ft generation file. These two files are created. Let's talk about what is importance of each file. So it has two files, shared FT file, which is found on a shared data store. It is the fault tolerance metadata file. This file contains the primary and secondary VMs UUIDs, that means universal unique identifications. This information is maintained by this shared VMFT. Because we don't know all of the sudden primary host down, in future this UUID2 become as a primary, again it will create another UUID. All this shared UUID information is taken care by shared.vmft file. And vSphere FT avoids the split bin situations, that means which can lead to two active copies of your virtual machine after recovery of a failure. Even if you recover this recovery is back to normal also, this .ft generation file ensures that only one VM instances is designed as a primary VM. There will be no secondary copies. It's always maintain one VM as a primary VM. Let's say UID1 VM is down, this secondary UID2 become as a primary, and also using the FT functionality, it's automatically prepare a secondary copy. Then after some time, if your primary host is up also, it won't create a FT VM because it's the FT generation file. It knows that there is a one primary VM is running. Okay, this is the vSphere FT functionalities. Okay, now let's verify the in our lab how we going to enable a vSphere clusters. FT features. The first one we familiar, will quickly run through the create a cluster, enable HA DRS and add the ESX host to cluster. Also this option we are familiar. We'll quickly run through the one, two options as well. And finally, we can turn on a fault tolerance for a virtual machine using the vSphere client. And then we'll test the vSphere FT functionality and view the vSphere cluster resource usage. Okay, let's log into the vCenter. In our vCenter server, we have a clusters enable production cluster and test cluster. Suppose for our easy understanding, I'm just removing one host from our cluster just for testing purpose. Let's say this test VM, no VMs are running here. Even if you want to move out your host from the cluster, just place the host into maintenance mode first. When you place the host into maintenance mode, then you can try to move your ESXi host from the move out from cluster. So just drag and drop it to the data center. So when you drop it under data center, see if I just drill up, you can see 3 clusters that our ESXi3 is running outside. Okay. So now if you want to create one virtual machine, we can create and test it. Exit the maintenance mode. Okay. Now we'll quickly create one test machine. FD test VM01. Creating on ESX3 for the time being, choosing the local data store and choose the default options, and CPU, let's go with minimum. Let's say 512 MB, not GB. Let's say 2 GB. Okay, and hard disk, we can change it to the 15 GB, and hard disk type, we can make it as a thin provision. Okay, now click on next, finish. Invalid configuration device. Let me recreate again. Let me create on local. Okay, maybe 2019 have some minimum requirements. Click on finish. So virtual machine is created, and the OS we can mount and install. But before install, just trying to power on this VM. Let's say VM is in power on state, but there is no operating system. If you want to enable the fault tolerance, right click the virtual machine. See, when the ESXi host is running directly under the data center, it's not under the cluster. I'm just trying to show you this option. Why VFT is considered as cluster feature is, let's say this is ESXi host, it's running in your vCenter, but if I select one virtual machine, right click, fault tolerance, all options are grayed out. But these options are enabled only when we move your ESXi host to cluster. Okay, so that is the reason in our lab, the first option is first we require a cluster to enable a fault tolerance. And during the creation of cluster, you can for FT minimally required HA and DRS required only when you have a EVC option. Okay, so these two options are required to go for a FT lab, and then you can add your ESXi host to cluster. So we'll do the same now. So if I want to add this ESXi host to production cluster, even in the production scenario, we can just drag and drop, and it will says that we have to all the resources on the ESX will be adding to the cluster. Okay, and we are receiving the error message. The reason is some CPU compatibility error, and also while you are moving the host to the cluster, recommendation is place the host into maintenance mode and move it. So let's power on this FTVM. Power off this VM, and right click the host, place the host into maintenance mode. Now it is in maintenance mode. Now just drag and drop it to the production cluster. Click on OK. See, now it's successfully moved to the production cluster. So we know how to create a cluster and enabling a HA DRS features. So the features are available from configure tab, edit, and turn on the HA. And same way, DRS also go to the cluster, configure, edit, and you can turn on the DRS. So DRS and HA already turn on. If you see from configuration tab, DRS, it's in the turn on state, and the HA also turn on state. Okay, now you can exit the ESXi host from the maintenance mode. So ESX already exited, and if you want to turn on the FTVM, you can just turn on. Now we have one virtual machine which is running on a shared data store. Before turn on the fault tolerance, let's quickly observe our VM kernel port groups. Suppose if you go to the network tab, we have a VM network is running. If I want to enable a fault tolerance, either you can create a network on a either virtual switch level, or you can create a new distributed virtual switch. So any scenario is fine. So for example, I'm creating a one network here. Just go to the cluster, ESXi host, configure tab. Under the virtual switch, you can just standard switch. We have a VM network and management network. If you want to add a additional network, you can just enable the network. Management network, even if you want to enable a fault tolerance, we require a VM kernel adapter. Okay, the VM kernel TCP IP stack handles the traffic for ESXi services, such as for vMotion scenario, we need VM kernel, iSCSI shared storage, and NFS shared storage, we require a VM kernel. Similarly to FCOE, even for fault tolerance feature, we require a VM kernel port group. Okay, so if you want to create a dedicated VM kernel network port group, you can create, or else even you can just create a port group and enable the fault tolerance logging on a all the ESXi hosts. So you can enable from here, or the another alternative method is we can create a new distributed virtual switch. If you want to create new distributed switch, go to the configure actions and create a new distributed virtual switch network. We can create the new distributed switch, or if you want to create a VM kernel port group on individual vSwitch also, we can create. Before adding that, first we need to verify whether we have enough NIC cards or not. ESX1, physical adapters. Okay, already there is a production switch. Okay, production switch is there. But somehow production network is not showing here. Okay, let's quickly create the networks. Let me open the spreadsheet for the IP address. Okay, we have 75, 76, 77, 78. These four IPs we can use. Before use, you can just ping this IP, whether it is free or not. Okay, it's using already. Okay, let me choose the another one. Maybe we can start from 84, 85, 86, 87. Okay, 84 is free. 85 also free. 86 free. Okay, these four IPs we can use. Let's log into the virtual switch and add networking, and we can choose the network for a fault tolerance network. So I'm using a default existing switch. and let's choose the VM port group for FT. So I am using the name as same name VM kernel -FT, and you can just enable a fault tolerance logging network. Okay, enable this option, click on next, and now we have to assign a IP address. So IP address we are planning to choose from 84 to 87. So let's start with the 84. Okay, and override the gateway, click on next. So FT is enabled here. The main service enabled for this VM kernel is FT logging. Click on finish. Okay, and similarly, another host, go to the vSwitch 0, add networking, click on next, and the same vSwitch, and the name we can choose VM kernel FT, and enable the fault tolerance logging and assign the IP address 85. Some of the details is auto filling. Click on finish. So same to the ESX3. Maybe recently I did some tests. There is some issue with the DV switch. I will check it later. So that's why I'm using a virtual switch now. And enable the fault tolerance logging. '86 and assign all the details. Finish. And now ESX4 also same. Port group name, same label name we have to maintain. Network label name. Okay. Network label name is nothing but a port group name. And fast tolerant, fault tolerance logging, click on next and assign the IP address. Now the IP is 87. But normally these IP settings in the real-time scenario, we will get it from a networking team. They will help us to share all the free IPs. So now VM kernel network port group for FT is already enabled. So we have enough a fault tolerance network able to connect it to the physical network for all our 4 ESXi hosts. Now it's the time to enable a virtual machine. But also as per our fault tolerance conditions, it is also recommend to have a second data store. We'll try to test with what is error message we will get. If no error message, we'll just observe the FT enable options. If we really require second data store, we'll create a second data store also. So right click the VM, go to the fault tolerance, turn on fault tolerance. See if you now earlier when the ESXi host is out of the cluster, we are unable to enable this option. Only with HA and DRS cluster, we can able to enable a fault tolerance turn on option. Okay. Now select turn on fault tolerance. See there is some existing error messages. So we can try to understand what is error message. The first option error message is the fault tolerance configured of the entity VM has an issue. The virtual machine has a video device 3D is enabled. Okay, maybe we can disable the 3D option. Okay, the 3D graphics are not recommended for fault tolerance, so we can disable. And another one, memory hard plug is not supported for the virtual machine. Okay, this is also one requirement. Even if we enable the memory hot plug, that needs to be disabled because memory is always fast tracking the copy from source to destination. So we can disable the hot plug option also. And another point, device video card is not supported. The device is not support for fault tolerance. Okay, we can disable video card 3D and also these options we can try to fix now. Click on OK. Let's if you want to disable the hot plug option, we have to turn off the virtual machine. So power off. So VM is in power off state. Go to the edit settings. Now look for a video card options. See video card, this is option. Just uncheck the video card and also this option auto detect. Uh, or I'll just select here any remove option for video card. Okay, these options we have remove, but this one there is no remove option. Okay, but I just uncheck the 3D option. Number of display. Okay, let's look for another option. What they are saying is memory should be hot plug should be disabled. Okay, disabled. Now click on OK. We'll try to power on and enable a fault tolerance. Even when the VM is power off also, it's allowing to turn on. We'll see quickly any other error messages. So this time seems to be no error message. So we are selecting a same hard disk. Okay, just click on same shared data store. Okay, now click on next, and the host is default. It is show all host. See, all hosts are showing. Currently where this VM is running, let me cancel. This VM is running on a ESX2. So that means the secondary copy should be the different host. So turn on FT, select the host, select the data store, sorry. Now select the host. See, fault invalid affinity settings. Okay, data store is being used for both. Okay, they are giving a warning message, but in our home lab only, we are okay to use the same data store. But in the production scenario, remember that we should not choose the same data store. Always a secondary copy will be on a different data store. Just for testing, I'm just choosing. So that is the reason there is a warning message. Warning message, okay to ignore. Now click on next. So it is going to prepare a secondary VM. So placement details for secondary VM is going to create on ESX01. Now click on finish. Okay. When you click on finish, we can just try to observe what is the changes is going on recent task. See, turn on fault tolerance. See, registered secondary VM with the primary VM, because we are choosing a same data store. Suppose if you choose a second data store, the network copy, like our previous lab, when we deploying a clone and template, it took longer time because all our ESXi hosts is running in a nested environment. If I choose a different data store, it copy may take longer time. That is the reason I'm just testing purpose. I use the same data store for both primary and secondary. But remember, production scenario, we always maintain secondary VM on a different data store. Not recommend to maintain on a same data store. Now the fault tolerance turn on is completed and the registered secondary VM is already registered with primary VM. Okay, we'll try to observe whether what is a secondary VM. See, if you see here, primary VM, secondary VM, both are created. Which is primary and secondary? How we can see is just go to the cluster virtual machines tab, and here same like our cluster status, it will show here which is primary and which is secondary. See, if you see the secondary VM, secondary copy is in a grayed out color, and it's not recommended to turn on. Always keep it in a power off state. By default, whenever it is necessary, even if we turn on the primary VM, we'll see what is the status for secondary VM. I'm just turn on the primary VM, and it says that this operation is not allowed in the current state. vCenter was unable to find a suitable host to power on the virtual machines. So maybe I accidentally clicked the primary VM only. I'm trying to power on. vCenter disabled the fault tolerance because secondary VM could not be powered on. Okay. Okay. In this scenario, what we can do is we'll just turn off fault tolerance first and re-enable fault tolerance again. When you turn off the fault tolerance, the secondary VM automatically removed. See, VM is managed to power on now. And if I launch the console, this VM is logged in with a Windows 10 operating system. Okay, Windows 10 is able to log in here. Now, what I am going to do now is when the virtual machine is power on state, we'll turn on the FT now. Fault tolerance, turn on fault tolerance. So select the data store next and choose the ESX host. See, there is some warning messages. Okay, we can safely ignore the warning messages at present. So host is ESX01 finish. So when you click finish, see, secondary copy is created. Okay, even this VM name is showing as primary, secondary is in a disabled state. That means users can access only the primary VM. Okay, if I go to the clusters tab and virtual machine tab, you can see clearly primary is in a power on state, secondary is in a copy state, power off state. Okay, and now the primary VM is running on which host? It is running on ESX2. Just for our testing purpose, we'll quickly turn off the ESX2 and we'll see whether the secondary is becoming a primary or not. Okay, so if you want to turn off this ESX host, just copy the host name, connect to the SSH session. Let me create a desktop shortcut. Okay. Now connect to the ESX2. Oh, seems SSH disabled again. ESX2, go to the services section, SSH, start. Okay, it started, and select here. We can edit the startup policy. We can always choose the start and stop with the host. We no need to start manually every time. We'll use this option, click on OK. So next time, even if we restart ESX, still in the running state. Restart the host session, root. Sorry, I typed in a cap uppercase. Let me launch the new console. Okay, once I log into the ESX2 and type the command reboot. So once the ESX is restarted, we'll see the difference of it will secondary VM become as primary and it will prepare another copy. See, already ESX2 is restarted. Even if you want to see the restart status, we can see from our workstation ESX2. See, reboot is in progress. Okay, so now we'll log into vCenter and observe the primary VM status. Let's refresh the console. See, now there is a primary VM. That means even if you see the cluster, there is a primary and secondary, even there is no impact. If I open a primary VM, where the primary VM is running, oh, okay, still it is not yet created another copy. Yeah, see the primary VM is running on a ESX1, Windows 10 virtual machine 1. So there is no impact to the VM layer, zero downtime. Immediately it's turned on a ESX1 secondary copy become as a primary. If you want to observe again, select the cluster, go to the virtual machine tab, see primary, secondary created immediately. Suppose if I select the secondary copy, where it is created the secondary copy, it's created on ESX1. How about primary? Primary also ESX1. Maybe both are created on same host. Maybe after some time it will migrate it to the another host. Okay, so but during this observation, even though ESXi host down or virtual machine down, there will be no impact to the production virtual machine. That is the importance of fault tolerance. Clear? And but the real-time scenario, we should maintain a high network speed and we should maintain a 2 data stores. Okay, minimally 2 data store and ESXi host also minimum 2, and recommendation is at least 3 ESXi host. Okay, so that is about the fault tolerance creation. Let's log into the lab. Yeah, if we see the cluster we observed, HA DRS we verified, and adding the host also we verified. We turn on the fault tolerance on virtual machine using Vsphere client, and we tested the Vsphere FT functionality and view the cluster resource usage. Okay, now go to the vCenter, select the cluster, go to the summary tab. From the summary tab, we can see all the information, data center information. See, vSphere HA failover in progress. Earlier warning, when the host is restarted, HA also initiated. Okay, just reset to green, and memory usage is currently high. Okay, because our lab host is running with high memory, it's fine. And the data center name, cluster consumers tag, and in the right side we can see the some additional attributes. vSphere HA resource usage information, custom attributes like advanced options, and the cluster service health status, and DRS score. Even DRS score also currently it is in the healthy state. Okay, so this is about the summary tab only. We can see all the clusters resource usage information. Okay, and if you want to see primary secondary VMs, select VM virtual machines tab. Here only we can see which VM is turned on the FT. That is a primary, always one primary, one secondary. Okay, the most of the user changes always will be on a primary VM only. So now we until now we covered the vSphere cluster fault tolerance feature. Now we'll talk about a vSphere features in real-time scenario. What is the key features is used? Okay, we'll quickly run through the real-time scenarios. vSphere features in real time. So let's say first feature. They are asking about the customer is requested to add ESXi host to production data center and let vSphere balance the load across the ESX host. So which feature is required in this scenario? They want to add the ESX host to production data center, and within the vSphere, they want to balance the load across the ESX host. So which is the recommended vSphere feature for this scenario?
DRS.
Yeah, we require a DRS, distributed resource scheduler. Good. So we can create a vSphere cluster and enable a DRS feature to balance the load among the ESXi host. Let's talk about the another scenario. Let's say there is a business critical application and the customer required a 99.99% availability as per SLA, and downtime per year is 52.56 minutes. That is the service level agreement. So in this scenario, which features are required in our vSphere?
HA.
We require a HA. Okay, and also suppose within that HA scenario, any specific VM, he required a 100% availability. We require a FT. Okay, so we can use for 99% availability, we'll go for HA, and if you require a 100% availability, we can go for a fault tolerance. Okay, and another scenario. Let's say customer wanted to identify virtual machine that are experiencing serious resource contention. There is a resource contention issue. So where we can see virtual machines having a resource contention, which is the vSphere feature is help us to identify the resource contention.
DPM.
Which one? Sorry. Can you please repeat?
DPM.
Resource contention. DPM is mainly for a underutilized scenario. For resource contention means we can identify. Yeah, DRS score. Using DRS score only, we can able to identify the resource contention. Very good. Suppose if we log into our vCenter, just now we verified, right? Under summary tab, we can see DRS score. Suppose if it is in a 60 to 80% means the health condition for resource is healthy. Suppose if the resource between 0 to 40% means health is not condition, there is a some resource contention. You can see from the cluster summary tab or go to the monitor, look for a DRS score. See virtual machine DRS score. Using this option also we can see the percentages. If it is 199 means it is in the healthy condition. If it is 0 to 40% range, there is a resource contention. So we can use the feature for this scenario is VM DRS score. Okay, it needs to be validated from cluster monitors tab VM scores. Okay, virtual machine DRS score. And another scenario, customer has requested to certain VMs by ensuring that they always run together on the same ESX host. The condition is the specific VMs they want to run on the same ESXi host. So during this scenario, which vSphere feature we can use? In our previous lab, we talk about a DRS rules, DRS affinity rule and anti-affinity rule. But when we want to create both virtual machines to run together on same ESX means it requires a VM host affinity rules. Okay, so it requires to be configure virtual machine host affinity DRS rule. Suppose if the customer is requested for separate ESX host, during that scenario, we'll use vSphere DRS host VM host anti-affinity rule. Okay, so this is the some of the scenarios depends on the customer requirement. We'll go with a necessary cluster features. Okay, so that's it for today. If you have any questions, let me know. Okay, if no questions, we can end the session here. And before closing the session, we'll quickly update our checklist. Let's say in our previous session, we talk about the Vsphere HA. So let's make this as a completed. And just now we discussed about the fault tolerance feature. So this feature also done. Okay, and in our next session, we'll talk about the other features like storage DRS, and we'll also talk about licensing. Some of the features I will cover in the next session. Okay, we are almost closing to the remaining very few topics only we have remaining. Okay, and please practice all the topics. If you have any questions, let me know. Okay, so that's it for today. Thanks for your time.
Thank you. Thank you.
Yeah, thank you. Bye for now.